Let us find the number of real numbers which satisfy the equation x times mod of x minus 1 minus 4 times mod x plus 3 equal to 0. So we want to solve this equation. Let's call this as equation 1. Now you see that mod x is positive when x is greater than 0 and negative when x is less than 0. Similarly, mod of x minus 1 is positive, so when x is greater than 1 and negative when x is less than 1. So we look at the following three cases. Case 1, x greater than 1. In that case, both mod x and mod of x minus 1 remains positive. So we consider the case x is greater than or equal to 1. In that case, mod of x equal to x and mod of x minus 1 equal to x minus 1. Therefore, equation 1 can be written as x into x minus 1 minus 4 times x plus 3 equal to 0. We simplify this equation to obtain x squared minus x minus 4x plus 3 equal to 0. Further, we can add minus x and minus 4x to obtain x squared minus 5x plus 3 equal to 0. This is a quadratic equation of the type ax squared plus bx plus c equal to 0. Roots are given by x equal to minus b plus minus root over b squared minus 4ac divided by 2a. Therefore, x equal to minus b. So, minus of minus 5 plus minus root over minus 5 whole thing square minus 4 into 1, a equal to 1 into c divided by 2a, 2 into 1. Minus of minus 5 is plus 5 plus minus root over 25 minus 12 by 2. That's equal to 5 plus minus root 13 by 2. We have assumed x to be greater than or equal to 1. Is 5 plus root 13 by 2 greater than 1? Yes. What about 5 minus root 13 by 2? But root 13 is greater than 3. 3 square is 9 and less than 4. 4 square is 16. Therefore, minus root 13 is greater than minus 4 and less than minus 3. Now we can add 5 to both throughout and subtract by 2. So 5 minus 4 by 2 is less than 5 minus root 13 by 2 is less than 5 minus 3 by 2. That is 5 minus root 13 by 2 is less than 1. But we want in this case x to be greater than or equal to 1. So we got only one solution in this case. So only one number of solution. Now let us look at the case 2. Let us consider case to be x less than or equal to 0. So mod x is equal to minus x, mod of x minus 1 equal to minus x plus 1. Therefore, equation 1 can be written as x into minus x plus 1 minus 4 times minus x plus 3 equal to 0. Once again, we can reduce it to a quadratic equation of the standard type. Let's do it. 1 into minus 1 is minus, so minus x squared plus x plus 4x plus 3 equal to 0. So that can be written as minus x squared plus 5x plus 3 equal to 0. Let's multiply by minus 1 throughout and we obtain x squared minus 5x minus 3 equal to 0. Once again, this is a quadratic equation. Roots are given by x equal to minus b, so minus of minus 5 plus minus root over b square minus 5 whole thing square minus 4 into 1 into minus 3 divided by 2 into 1. Let's simplify it. Minus of minus 5 is plus 5 root over 25 plus 12. 25 plus 12 is 37 by 2. As we are assuming x to be less than or equal to 0, we are bound to reject x equal to 5 plus root 37 by 2. Further, we observe that x equal to 5 minus root 37 by 2 is less than 0. Therefore, a solution. So we got one more solution in this case. Let us consider the last case when x lies between 0 and 1. In this case, mod x is simply equal to x, mod of x minus 1 equal to minus x plus 1. Therefore, equation 1 can be written as, so in third case, x is lying between 0 and 1, so mod x is simply equal to x, mod of x minus 1 is simply equal to minus x plus 1. Therefore, x time mod of x minus 1, x time mod of x minus 1, let's copy the equation, minus 4 times mod x plus 3 equal to 0, minus 4 times mod x plus 3 equal to 0. That implies x, mod of x minus 1 is simply equal to 1 minus x, minus 4 times mod x is simply equal to x plus 3 equal to 0. So that can be written as minus x square plus x minus 4x plus 3 equal to 0. And so minus x square minus 3x plus 3 equal to 0. Once again, this is a quadratic equation. Let's cancel minus out. So to get x square plus 3x minus 3 equal to 0. Roots are given by x equal to minus b, so minus 3 plus minus root over b square, so 3 square minus 4 into coefficient of x square, that's 1, into c minus 3 divided by 2a, 2 into 1. So that's equal to minus 3 plus minus 9 plus 12 is 31. 9 plus 12 is 21 by 2 as it is. Now we want in this case x to lie between 0 and 1. So we reject minus 3 minus root 21 by 2 comma x equal to minus 3 plus root 21 by 2. Definitely this is greater than 0 and it is less than minus 3 plus 21 is less than 25. So minus 3 plus root 25 by 2, and that's equal to 5 minus 3 is 2. So 1, definitely it is less than 1 and greater than 0. Therefore, we got one more solution. In total, in each case, we observe that we are getting exactly one solution. Therefore, number of solutions to the given equation is 3. In other words, we have got exactly 3 number of solutions to the given equation.